So we finally reached Module 11, where we'll actually start designing and implementing our own classes. Here are the learning objectives for Module 11. In all the weeks up until this point, we've been focused on using classes that are provided by C# or by XNA or by me in the course materials. And so that's an important first step with dealing in object-oriented systems, learning how to use classes and objects that are available to you because of work other people have done. Now it's time for us to start actually working on the design and implementation of our own classes. And so that's what we'll do within this module. We'll do a class for a console application, and then we'll do a class for an XNA game as well. You should recall from way back in Module 4 that objects have three different things. They have state, they have behavior, and they have identity. And so the state of an object is all about the characteristics of that object. So you should go do an in-lecture quiz about demonstrating that you remember how we actually store the state of an object. And now you should do another in-lecture quiz that demonstrates that you remember how we actually provide consumers of the class that the object is an instance of, how we provide consumers access to the state of that object. Okay, so the next thing that we worry about or need to be concerned with is the behavior of the object. So what can that object do? Or, interestingly enough, what can we tell the object to do to itself? So another in-lecture quiz to demonstrate that you remember how we do that part in C#. And finally, we have identity. Well, objects have identity. We do too, but objects have identity. So this lets us distinguish one object from another. And so the third thing we need for objects is, of course, identity, and we will actually get identity when we call the constructor to create a new object. So let's build a die class. A die is a thing that we roll. It has a certain number of faces, and so we'll come up with a design for a die that corresponds to a die in the real world. And so first, we'll start with state. What are the kinds of things that we need to store for state in the die class? Well, we need to remember how many sides a die has. So a standard die has 6 sides. But if you happen to be a Dungeons & Dragons player, maybe you think a standard die has 20 sides. And so we need to store within the die how many sides it has. And we'll tell it how many sides it has when we actually construct the die object, just as the die factory determines how many faces are on the die when they actually build the die in, a physical die. So we'll have to keep track of that for state and how many sides there are. And we'll also need to keep track of which side is on top, because typically people will use one or more dice for a game. And so you roll the dice and you look at the number that's on top and you do something with it, whether you pay money or you move forward on a board, or the orc has slashed you fatally or whatever. But we use the number on the top of the die for some particular reason. So we're going to need to store that as well. And so, as you know from the earlier in-lecture quizzes and your work with C# so far, we're going to store the state of the object in fields, and then we're going to provide consumers access to the state of the object through properties. Next thing is behavior, and we're only going to do one thing for behavior. We are going to tell the die to roll itself. So that's how we'll use dice. We'll tell a die to roll itself, and then we'll look at the top side and say, oh, okay, now I know what's facing up, and take the appropriate action based on the game we're playing. And finally, we of course give each die object identity, And that will happen when we call the constructor to actually build the die object. So sort of pictorially, this is what we've come up with. So remember the information hiding thing. We're going to hide the fields, numSides and topside, in the internals of the object. So a consumer of the object can't see those things. And that way, if we decide we want to change how we represent those things later, we can without affecting any consumers of the object. So that's the information hiding part. Encapsulation, remember, is putting the data, that stuff in the inner hole of the donut, I must be hungry right now, the inner hole of the donut, encapsulating the data along with the behavior. And the behavior in our case is rolling the die as a method. And that capsule, the membrane of the capsule, also makes it so that consumers access the data through those two properties. So they get at the behavior through the method, and then they get at the data through the properties. That previous picture was not in any standard pictorial form. This is in fact the UML diagram for the class that we're going to build. So as you can see, we have the fields that we'll use to store the state internally. And then we have the properties that a consumer of the class will use to access that state. And then finally we have the method so they can also get at the behaviors. We typically do not include the constructor, one or more constructors in the UML diagram, so I haven't done that here, but understand that of course we'll have at least one constructor so that we can in fact create new instances of the class. So now let's actually start doing this. So I'm going to start up Visual Studio. Now we're going to start a new project. This one's going to be a console application. So I'll say it's a new project, a console application, and I'll call it die. Okay. I guess I can't. I'll call it die example. I can't bring myself to just call it die. So I'm going to create this new project. I'm going to zoom in immediately, and I'm going to save. So I will go save, and then we'll jump back into the video. Okay, so I have saved it, and I also snuck in and added comments. Almost all the comments that I should have added. There we go. So we want to actually create a new class, which means we need a new file. And so over here, where it says die example, the bold-faced, this is the project, I right-click that, and I say add a new item at the top, or pick the class at the bottom. It's so common for us to add classes that we get our very own option in the drop-down for that. I am going to add a class, and I'm going to rename it die with a capital D. And I'm going to zoom in. And so this is a die. Now, I will F6 just to demonstrate that everything still works. Now, the first thing I'm going to do is add the fields for the class. So I'm going to add a region. And remember that region, using regions is just for within the IDE. It has nothing to do with what gets executed when we actually compile and run our code. And so I knew that I needed two things for fields. I needed the number of sides for the die, and I need which side is on top. So both of those really ought to be integers. We really can't have dice with 6.5 sides. As soon as you cut it, there's an extra side. That's why diamond cutters are so rich or something. I don't know. Okay, so they're both ints. So I'll call the number of sides numSides, just as we saw in the UML. And I'll call the top side that we're saving topside, just as you'd expect from the UML. So at this point, I can compile again. But I have added both the numSides field and the topside field to this new class that I created. You should now go do an in-lecture quiz that asks about controlling access to these fields, and then come back and we'll talk about it. So a new thing that we haven't talked about yet because we haven't been developing our own classes is that there's another word that can go here before we put the data type and the variable name. Up to this point, right, this is just exactly declaring a variable because it is a variable within the class. But we can also set what's called an access modifier. So we can, if we choose to do so, we can do something like this. Say public. We could make our numsides field public, which means that any consumer of this class can directly manipulate our numsides field. And that is generally considered very bad programming practice. We don't care about it for constants. It's okay to make constants public. We don't have any right here, but it's okay to make constants public because nobody can mess them up, essentially. But making a field public, really bad idea. If we do that, we have basically taken our picture of the class and we've done this. We've said, okay, you can directly manipulate numsides, so I'm going to dig a hole. I'll break that information hiding thing so that you can tunnel your way into the core of my class and mess around with the internals. That is such a horrible idea. It is allowed by the language, but it's a terrible idea. You should never do it. Let me X this out lest you think that that's the best thing ever. So really what we want is we want all of our fields to be private. We don't want anyone external to the class to be able to see those fields in any way. And because we want them all to be private in general, and because it is such good programming practice, they're actually private by default. So really, for changing the access modifier for a field, the only way for you to mess up is if you deliberately decide to be a bad programmer. Morally bad, not just, bad code quality, just a bad person. I'll make this public. So don't do it, right? It breaks our information hiding, and there's no need to do it, because if consumers of the class need access to the state, which is what our fields are for, then we provide them access to that state through our properties, which means we should actually implement some properties. So I'm going to create another region. And here's where I'm going to implement our properties. So let's implement the numsides property first. We need to put an access modifier for the property, and because this is for consumers of the class, we want to make properties public. In general, we want to make properties public because the consumer of the class needs access to it. The numsides field is an integer, so we're probably going to want to return an integer here as well. And properties are capitalized. So just as methods are capitalized, just as class names are capitalized, properties are capitalized. We put an open and close curly bracket, and I'm going to talk about the syntax for both things that we can do within a property, and then we'll get rid of the one that's just crazy. Okay, so the two things we can get for the two things we can do for properties is read them. We say we can read the property. We implement the read capability for a property by providing a get accessor, and we can set the property. So basically, we can get the value of this state information, sorry about that, the state information, numsides, and we can set the information. So I'll implement both, and then I'll get rid of the one that's dead wrong. Okay, so to get numsides, what we're really saying is go through that picture, I'm accessing the property, and you should tell me the information that you have hidden in your core. And so that is definitely numSides. So we need to somehow get the value of the numSides variable. And we get the value of variables by just putting the variable name. But now we need a way to actually return this to the person, the consumer of the class, who's trying to access this property. And the good news is programmers are crazy, but sometimes we use appropriate words. So if we were to return something, we use the word return. And so by putting return numSides, when someone tries to access this property, we can just give them what is in that property. So that's get. That's actually get that's the read, find out. There is a write possible in properties. It's done within the set accessor. And so the way we do it is we say numSides equal, so we're trying to set the value of this field. So numSides is equal to something. And that something is a special keyword called value. When it's time, oh, you've actually already seen this, right? When you did bear.active equal false, that false part, when you're accessing a property, you're accessing the set accessor for the active property, and inside the property, which we didn't look at, but inside the property, that false that you had on the right hand side of the equal was actually called value inside. So that's how we'll see this again. Don't worry when we implement the XNA stuff, because boy, it makes sense to actually find out the number of sides on a die, but it doesn't make any sense at all to let a consumer of the class change the number of sides on the die once it's been created. What, are you going to take a file and, make new faces on the die and color them in with magic marker or something? No, definitely not. So this particular property, it only makes sense for it to have a get accessor. And we'll add a comment, gets the number of sides. Now the only other property we said we needed was the top side. So let's do that as well. And just as for numSides, it only makes sense to have a get accessor for top side. If you could roll a die and then reach over and turn it so that you got a better roll, dice games would not be nearly as interesting as you might expect. And if you want to, travel to Las Vegas and try that at the craps table, you'll probably get in trouble from the casino. Okay, so just get. We can look at the top side, but we can't change it. Okay, so same exact thing as above, except this time we'll return top side instead. And of course, we will add a comment. So that either somebody reading the source code or the documentation we generate clearly indicates what gets done. Okay, I'm going to F6 so I can build. And I can F5, or I control F5 because this is a console app and it's not exciting at all. So you might think that we should definitely test these properties right now. And while I would agree with that, the problem is we don't have any constructors yet, so we haven't created any die object yet, so we can't access the properties of a non-existent object. So we will actually start testing these properties in the next lecture. And speaking of the next lecture, this is the end of this one. So we've done our design for the die class, and we have implemented the fields and properties. So we've handled the state part of what we need from state, behavior, and identity. And next time, we'll actually build a couple of constructors for the die class.